Welcome to the mathematics class. In this video, we are going to discuss about cycle, the subtopic of angle properties. This is episode number 3. Make sure you subscribe on my YouTube channel in order to get more tutorial videos concerned with mathematics subject. Subscribe on it. Okay, let us start. The first subtopic concerning with the central angle and degree of an arc. Here I will find the relation between the central angle and degrees of an arc. Okay, assume you have a certain cycle like this one. This is your cycle. From this cycle, assume here is the center of a cycle. So this is the center of this cycle. Let me call it O, center of a cycle. Then here you have two radii, the first one and the second one. Okay, this one is the central angle. Let me call angle theta. Assume this is point A and this one is point B. This distance from A up to B, the circular distance, is what we call an arc. So we're going to check the relation between central angle and this arc AB. Okay, the degree found on this arc AB will be equal to the degrees found at the central angle. That's why I can say degrees of this arc AB will be equal to central angle theta. So the central angle always equals to the degrees found on an arc. Okay, let us move. Now we're going to find the angle at the circumference and the degree of an arc. What is the relation between the angle at the circumference and degrees of an arc? Okay, for this one also, assume we have a cycle like this one, and from this cycle, assume here is the center of a cycle. Let me call O, and from there I will make a certain angle at the circumference of this cycle, this one. Okay, let's say this is angle point A and this one is point B. This one will be the angle at the circumference of a cycle. I want to find the degrees found on this arc AB. Okay, because here is the angle at the circumference and this one is its respective arc, then I can say the degrees of an arc AB, degrees of arc AB, this one will be equals to 2 times angle at the circumference. Okay, so now you have to note, in order to find the degree at a certain arc, when you have an angle at the circumference, then degree of that arc will be equal to 2 times angle at the circumference. Okay, this is just the introduction concerning this one, but let us proceed with our first theory. Okay, the theory says that angle subtended by an arc at the center of a cycle is twice angle subtended at any point on the circumference of a cycle. Okay, let us prove this one. Assume you have a cycle like this one. This is your cycle, and from this cycle, this one is the center of a cycle. Let me call center of a cycle O. Then from there, I have first radii here, and I have second radii. Let me call this is point A. This one is point A, and this one is point B. This one is point A, and this is point B. This one is a central angle. And also, I have another angle here at the circumference of a cycle. This one is a certain angle at the circumference of this cycle. Okay, let me call this is angle B. Then from there, this is angle A, do not forget it. Then from there, I want to prove that this A equals to 2B, means angle at the center equals to 2 times angle at the circumference. B is the angle at the circumference, A is the angle at the center. Okay, so now we're going to prove this one. Okay, in order to prove that, you're supposed to draw the certain line from this point, line like this one, and from there, because I know this one is a radius and also this one is a radius, since this is a central point, and also this one is a radius. From there, I will find this one as an isosceles triangle. Because this is an isosceles triangle, this angle must be equal to this angle. Let me call this angle is M. Okay, let me call this is angle M, and also this one will be angle M, this angle. And also, this angle actual must be equal to this angle. Let me call this is angle N, and this one must be equal to N. This is because this line is equal to this line. That's why this angle equals to this angle. And also this line equals to this line. That's why this angle equals to this angle. Okay, but how about another angle here? We have a certain angle. How about this angle? Let me call this is angle P. And how about this angle? Let me call this is angle Q. Okay, now from there, if you consider the first triangle, this triangle, when you take this M plus this P must be equal to 1/8. That means when you take that M plus M is equal to 1/8. When you take this M plus another M here, then plus P will be equals to 180 degree, because this triangle, it consists 180 degree. That's why when you take this M plus P must be equal to 180 degree. Okay, then from there you will find that this P will be equals to 1/8 minus 2M. Okay, that is the first one. But for the second one, when you consider this triangle, when you take this N plus Q must be equal to 1/8. This N plus this Q must be equal to 1/8. That means when you take N plus Q must be equals to 1/8, because that is another triangle. Then from there I will find Q equals to 1/8 minus 2N. Okay, but also do not forget, here we have point A. This one is point A. But when you take this P, this angle P plus this angle Q plus A is equal to 360. That means when you take this one angle P plus this one angle Q plus this angle A must be equal to 360, because that is a cycle. That's why when I take this one, when I take that P plus that Q, then plus A must be equal to 360, because that is a cycle. Okay, but P equals to this one and Q equals to this one. Now proceed. P 180 minus 2M, 180 minus 2M plus, what is Q? 180 minus 2N, then plus A equals to 360 degree. Okay, when I take this one plus this one, I'll find it equals to 360 plus, when I take this one, then minus 2M minus 2N must be equals to 360. Okay, now from there, this one 360 and this one 360, they're going to cancel, so you have to use this one. A minus 2M minus 2N is equal to 0. So when you shift this one to another side, you will find A equals to 2M plus 2N. From there, A will be equals to, shift out to get M plus N inside the bracket. Okay, but this M plus N is equal to B. This M plus N is equal to B. Refer from this one. Refer from this. This one is M. This one is N. But do not forget, this angle was B. That's why this M plus N equal to this angle, which is B. That's why I can say here, when you take this M plus N, the answer must be equals to B. That means our A now, our A will be equals to 2 times B. Hence proved. Okay, I'm proved for the first one. Let us take the second one. Here we have another theory here. The theory says that angle in the same segment of a cycle are equal. So angle in the same segment of a cycle are equal. They theory sometimes they say that angle with the same arc always are equal. Okay, how I can prove this theory will be like this one. Proof. Okay, assume you have a certain cycle here. Let's say this one is a cycle. Then from this cycle, we need to prove that angle on the same segment always are equal. Okay, now assume something like this one. Here is the center of a cycle, and because here is the center of a cycle, we need to create the certain angles which use the same segment, something like this one. Okay, let's say this is angle A and this is angle B. This one is what we call angle B. This is angle A and this is angle B. We have this one angle A and we have this one angle B. This angle A and angle B both use this arc. Let's call the arc AB. Let me write AB. Okay, both angle A and angle B, both use this arc AB. Okay, because both use arc AB, we need to show that angle A is equal to angle B. We need to show this one. Okay, so how I can show that one? I'm supposed to introduce another triangle here. Because this is point A, you can draw a certain line from here up to the center of a cycle, and also can draw a certain line from here up to the center of a cycle, because this is the center of a cycle. Okay, this is the center. Let me call it O. But this center of a cycle use arc AB. The center of a cycle also use this arc AB. And from the theory which says that the central angle is twice angle at the circumference. So if my central angle here is C, then central angle is twice the angle at the circumference. And then I can say this C central angle is equal to 2 times angle at the circumference. But here we have 2 angles at the circumference, this B and this A. So I can say this C will be equals to 2 times B, and also this C equals to 2 times A. So C equals to 2 times B, but also this C equals to 2 times B, but also this C equals to 2 times A. Why? Because we know that always central angle is twice the angle at the circumference. That's why C equals to 2A and also C equals to 2B, because this C is our central angle and this A and B is the angle at the circumference, and all that 3 angles use the same arc. And from this concept, you will find that if C equals to 2B and also this C equals to 2A, that means even this 2A must be equals to 2B, because this 2A equals to 2B also equals to C. So I can say this 2A will be equals to C, also will be equals to 2B, because this one equals to this one and also equals to this one. Also I can say this one is equal to this one. Then I can write this 2A is equal to 2B. Now simplify, divide by 2. Now I'll find A equals to 2B. Here A equals to, not to B, A equals to B, because this one they're going to cancel. So hence proved A equals to B. Hence proved something like this one. Okay, the last here we have exercise, so make sure you try it